not my favorite topic, food. I went to a coffee shop, I bought 1 coffee, and I got 2 croissants, and I spent $9. My friend also came to the coffee shop, and she was buying for a whole bunch of people. So she bought 8 coffees, and she also bought 4 croissants, and she spent $30. Okay? We're going to figure out the cost of 1 coffee and the cost of 1 croissant. And we're going to use a different method. So let's first just look at the situation. What did we buy total?
$30.
How many coffees did we get?
8.
We got 9. I bought 1 and she bought 8, so we bought 9 coffees. That's my attempt at a coffee. And how many croissants did we buy total?
6.
We bought 6. Her 4 and my 2 were 6 croissants. That's a bad croissant. It looks like shrimp. Yeah.
Ew.
It looks like a boomerang. I don't know. Okay, but how much did we spend total? 39. Okay. So now what you've just proven to me is that we could add equations together, right? If I needed to know my shopping order and her shopping order, I could combine them and represent it as one shopping order, right?
Yeah.
We just did that. 9 coffees. The total of 9 coffees and the total of 6 croissants would be a total of $39 because that's what we spent. So mathematically, it would look like this. We could add equations together, and there's going to be a reason why we would want to do this. You don't have to write this example down because this isn't the one we're going to use to learn this method. But we can add together. So instead of the visual of coffees and croissants, mathematically it would look something like this. If you had 4 x's and I had 2 x's, then combined we have 6. If you had 2 y's and I had 1 y, combined we have 3. And if you had 4 constants and I had 6 constants, together we have 10. Right? We can do that. So take a look here. This would be a good example if you wanted to write something down. If you had these 2 equations and I wanted to combine them,
5 white.
how many constants would I have?
1.
5. Yeah, 2
What?
and a 3. How many y's would we have? 5. Yeah, positive 3 and positive 2 gives us 5. How many x's would we have?
0.
0. Yeah. So now when I rewrite the equation, it looks like that. What do you notice? What happened when we added them together? Say it again. Say it again. How do you know that y equals 1? You solved that. Why were you able to solve this equation here, but we couldn't solve the ones in the beginning? What do you mean by it's simplified?
We only have
We only have 1 variable. What happened to the other one?
it canceled out
When?
when we added it.
So when I added the equations together, what did I do to that 1 variable?
You
Eliminated.
It was eliminated. Yeah, it was. They became 0. Right? That's actually there a 0x, but we know that we don't have to typically show 0 of something, so we can just represent this equation as 5y. So now we know that y is 1. David jumped in. He said, well, 5y is 5, so I know y is 1. If I know y is 1, what's x?
Oh, 0. Well, no. Well, yeah, 1.
1, 2, 3.
Oh.
Now I can substitute back in now because going back to the original, I don't have 2 unknowns anymore. We already figured out that y is a value of 1, so I can replace the y's here with 1. So the idea there was we combined and one of our variables actually combined to 0. What are the only numbers that can combine to 0?
What is that called? Integer?
A negative what and a positive what?
Integer.
Well, like in this situation, it was a negative 1 and a positive 1.
Negative.
What do we call those?
Absolute
Factors.
value.
Factors?
Coefficients.
Well, they're the coefficients in the equation, but we'll jump to another. We'll get it. Oh, we already did that. So this is elimination. The other day we wrote down the word substitution and we talked about what it was. Elimination is a different method to solving a system. And what we do when we eliminate one of the variables by adding the equations together. Just like the example we just did. We're going to look at a few others because some stuff can happen here. And we will continue to look at ways to eliminate and how to make elimination work for us. So elimination is when you eliminate one of the variables by adding the 2 equations together. So just like that previous example, when we added those two equations together, the x was eliminated and we were left with 5y equals 5. Just like when we substitute, and our goal was to go from 2 variable equations to a 1 variable equation, we did the same thing, but we didn't have to substitute. We actually just added them together and one of the variables eliminated. We're going to look at another example so that you can get a few different levels of elimination and you can see exactly why it works the way it does work.
Wait, what was
So let's try this. What would happen if I wanted to use the method of elimination? What would I do? Where would I begin?
Yeah.
for
We're going to add our equations. So we're going to add our equations together. And what are we going to have? What are our constants here?
-5,
Negative 5 plus 12.
7,
7. Negative 4y plus 4y.
0.
0. 3x plus a negative 10x.
X.
Can I solve?
Yeah.
Yeah, I can. Now I have an equation that I can solve. I can solve for x. X is what? Negative 1. To finish this off, how can I find y? I can go back to the beginning. I can substitute in x of negative 1 in, let's say, this equation. You can do either one. Negative 3 minus 4y. Someone finish that for me and tell me what y would be. And for those of us who need to see that visual here from the beginning, if we're adding, did you get y? What do you got? Positive 2? Did we get that? How did we get y alone here?
I added the -3 to -5.
So are you adding a negative 3 or are you adding 3?
Adding 3.
You're adding 3. Good. So then we have negative 4y equals what? What's negative 5 plus 3? Negative 2. And then y equals 1/2. Just like this. When we decide to use elimination, what do we have to be really careful of when we add equations together? When I'm adding stuff, right, whether we're solving an equation or we're solving a system, if I'm going to add terms together, what do I have to be certain of when I add terms? That they're like terms, absolutely. I can only add x's with x's, I can only add y's with y's, and I can only add constants to constants. These examples that you're seeing today are kind of stacked, like the x's are on top of the x's and the y's are on top of the y's. If you decide when you're choosing your own method, if you decide to use elimination, you may need to be really careful of that because the order might change. You'll see plenty of examples of that as we move forward. Okay. So that was another example of elimination. We saw that 4y eliminated with the negative 4y. Take a look here. What's going to happen when we eliminate? What are we going to get? What's going to happen when we add? We'll get 6x. Good. What else? Negative 1y. And then what else?
10.
What's the problem?
There's 2 variables.
Yeah, I didn't eliminate anything. Or I didn't eliminate anything. So we have an issue. I have quite a few values here. I have 2 x's, I have 4 x's, I have positive 1, and I have negative 2. Can I do something to this equation? Can I add 1,000 to this equation if I wanted to? Could I? Could I add 1,000 to this side of the equation?
Yes.
Yeah, as long as I do it to the other side. Like I can do anything that I want. right? Because if I do that and I make sure I do the same operation to both sides, is the value of my variable going to change? No. So can I do something to one of these equations to make sure that one of the variables does eliminate? What kind of numbers do I need in order for them to eliminate? Specifically what though? Like what numbers do you need to turn into other numbers? 'Cause there's a specific type of number that when I add it together, it'll give me 0. Plus opposites, absolutely opposites. That's really what we're looking for, right? -4 and +4, -1 and +1. Those are the examples we did so far. So the problem here is, do I have opposites? No. So I need to do something, anything, to make one of those equations change in a way that I would have opposites. What do you think we might be able to change? Anyone have an idea for what we could do to an equation to change? Oh, what do you think?
Add 2 to the bottom.
Just add 2? Like that?
To both sides.
To both sides. Is that going to help us eliminate a variable?
No.
So you're thinking about eliminating the y? Okay, if you want to eliminate the y, what would we need?
Plus
Add something to what?
Do you want to add 2y?
1y.
Or you want to add 1y? Alright, so if I add 1y here, that becomes 2y. But the problem is, if I add 1y here, where else do I have to add 1y? So I'd have to add it here. Now, the issue is that we might have eliminated the variable here, but we just brought it back. So is there something I can do where I wouldn't be bringing in necessarily another variable? We tried adding a variable. Is there anything else we can try? Or we tried adding a number. Dividing. What would you divide?
I don't know, I'm just throwing out ideas.
If I wanted to divide, could I do that?
Yeah, as long as you do it to both.
As long as I do it to everything right in my equation. So think about a variable that we may want to eliminate. We have the 2x and the 4x. We have the 1y and the -2y. So we thought adding was tough because we added a variable to the other side. You mentioned dividing. That might work. What other operations might work? Multiplying. What could you multiply by?
Oh, you can multiply the whole thing by 2.
If I multiply the entire top equation by 2, what does it become?
4x plus 2y.
4x plus 2y equals
Oh, yeah.
12. So now, can I eliminate?
Yeah.
Yeah, I can now. Yeah. When I add together, what do I get here? 4x and 4x? 8x. -2y and +2y? 0. 4 and 12? 16. So can you solve now for x?
Yeah.
I can. What's x? X equals 2. And if x is 2,
I'm not losing.
y is
Sometimes when you-
also 2. I'm going to follow it. So, good idea, Kate, that we can multiply. The nice thing about multiplying, notice we didn't bring a variable to the other side of the equation. We just made that variable that we needed to become an opposite. We were able to do that by doubling everything in that equation. Did we need to multiply by 2? When we multiplied by 2, we eliminated the y value. Could I have done anything to eliminate the x? Or is anyone writing down? I'm going to slide past. Think about, is there anything you could have done to eliminate the x? There's actually 2 things you can do. So try to find both of them. Hold on. From those original.
I know. I got one.
Oh, we already did that? Okay. So now, instead of eliminating y, what can we do to eliminate x? Who has an idea? Go.
You can multiply the top one by
I can multiply the top equation by -2, because that would become -4x minus 2y equals -12. and that would eliminate negative 4y equals negative 8. Y is still 2, just like before. What else could we have done? Hold on. What else could I have done? So yes, I could have multiplied the top equation by negative 2 to eliminate x. What else could I do to eliminate x?
Divide
Divide what?
the bottom one
By?
by 2.
By negative 2. Yeah, I could have divided everything in the bottom equation by negative 2. And that would have become negative 2x plus y equals negative 2. So then if I combined these, we get 0. These, we get 2y. And then these, we get 4. The nice thing about elimination is you have options. You determine what you want to do in terms of manipulating one of the equations. So in the first example that we did, there were already opposites that we could combine and then solve. We're not going to do I ready yet. I just want to make sure we all get this before we do that. Sorry. The second layer was we had to do something to one of the equations in order to make it eliminatable. I used that as a word today. I don't even think it's a real word. But I made it a word. Eliminatable. It sounds good. It rolls off the tongue. Tomorrow we're going to talk about doing something to both equations. That would be something a bit more complex. Now, you may have a preference. You might look at this and say, wow, this seems so much easier than substitution. And that may very well be the case. I had a student last year, he loved elimination. Even if the equations were set up to be substituted, he would find a way to eliminate because he just loved that method. And it's okay to have a preference. Right? That's why I wanted to show you all of them. So now let's go back to the beginning, to this equation. This was the situation in the beginning. Now, could we represent these orders as equations? What was my order? How would I represent that? X plus 2y equals 9. And how about my friend's order? All right, so I want you to take about 4 minutes. I'm going to actually pause the video after this. And I want you to use elimination and solve that system.
Whenever we do something